Hello and welcome to another Into the Terminal. Nate, what's that haiku?
Oh man, the slide just went away. Now I can't see. It's not DNS. It can't be DNS. It was DNS.
It was DNS. Today we're going to be talking about DNS. So why don't we just first cover kind of some of the client-side basics, and then later on we'll talk server-side. Let's jump on into the terminal. So a lot of the DNS-related tools that we were interested in are not installed by default on many machines. So the first thing we're going to have to do is install some of those tools. So we're going to do a DNF install bind-utils. Nate, do you know why it's called bind-utils?
I'm guessing because it was initially or maybe still part of the bind name server, and it's been split
Yes,
out because it's basically the client tools that go along with DNS resolution, which for a long time was synonymous with bind.
right. So bind is the Berkeley Internet Name Daemon. And this set of tools that we're going to use in just a second were authored to work with that service. And they're now kind of standalone because they're client side. You don't need to have the server side installed in order to use these client side tools. All right. So, real quick, generally, your machine will be configured with a DNS server with which it will use to query name lookups. And this is stored in a configuration file. Nate, I know you know the file.
It's the etsyresolve.conf, and it has been for, man, a very long time. Maybe as long as I've been using Linux. Has it ever been something else?
Bajillions of years, like
Yeah.
dinosaurs roamed the earth type of time. Um, and oftentimes, this file is actually generated for you by Network Manager.
Yeah.
And if that's the case, there's usually a comment at the top that says this file is generated by Network Manager, which means if you make changes to it when Network Manager is reinvoked, it could overwrite your changes with its own. But we notice there is not such a comment here, which tells me that this is populated by this machine. The things of interest in this file. The first one is the search line. So if I just use a machine name without a fully qualified domain extension, right? Like you could see in the prompt, this machine is named rel.
Yep.
So if I did a SSH rel and I didn't tell it the fully qualified name extension, it would use the search directive and the domain extensions listed in the search directive to try and figure out against my name server what actual IP address goes with this machine that I used in my command. So you can make changes to that as well, like go ahead and make an edit like that. So now when I use just the base name rel, it'll first do a DNS lookup for rel.usv blah, blah, blah cluster local. And if it does not get a positive response from the name server with that fully qualified name, it'll then try again with rel.example.com. And if it doesn't get a positive response there, then it will just go, I don't know what this machine is.
Right. Super
All
useful
right.
for local resolution. Not, I shouldn't say local, but like home or within your network. I'm trying to find the right term here. Resolution. That way, imagine that that's your company name or something like redhat.com. If you're looking for a host name at redhat.com, you don't have to type out that whole search or the whole domain, which is really handy.
Yeah. And also, when you're in an organization that's large enough, a lot of times they'll have subdomains, right? So it might be like
Right.
.devel.redhat.com, domain name managed by our engineering department.
Yep. Yep.
And so you could put those additional subdomains on your search directive too. One other note on search directive, it is order sensitive. So as you use a what we call bare name, right? Just that short name without a domain extension, it's going to try them in the order that they appear on the search domain, and it will stop at the first successful lookup. So it may not make all the way through your list of searches. It'll just stop where it finds its first successful lookup. And that's
Right.
weird because if you said SSH www, well, if there's a www machine in any of the search domains, or I should say in multiple of the search domains, you're going to get the one that's first matched, and it will ignore all the rest on that line.
I'm going to tell you, it's pretty uncommon that I've seen anybody set more than one search domain. Although it's nice that it's an option,
Um,
because that can lead to so much confusion, right?
yeah, well, DNS can be really complex. Like
It can.
even here at Red Hat, we have internal DNS and external
Yep.
DNS. And that's actually pretty common at large companies. So when you like use the VPN client to attach to a corporate network, you get additional DNS stuff to point to internal DNS instead of external DNS.
Right.
Um, but anyway, an aside.
Let's not rabbit hole, but yes.
Yes. All right. The next line is nameserver. So you can have one or more of these. And this is the list of servers that you want to connect to do those DNS connections.
And this is
So,
another case where, the first one that gets hit will be the one that gives you the answer. So if you for some reason have several name servers in here that maybe respond differently, like say you have a local DNS server and a public DNS server, and you really wanted the result from the local name server before the public, then you got to make sure the local is first in that list.
right. And so you can see here I now have two. One is a top level name server that runs on the internet, and the other one is one provided by my ISP. But I put the top level one first. Maybe that's not the appropriate ordering. Maybe I should put my local one first and then the
Right.
top one later on if my local one, for whatever reason, is able to get a request.
And the other thing that's really important, the reason you'd have more than one, except for like these dynamic use cases that we're talking about, would be for failover, right? If one of those is unreachable, it'll reach out to the secondary. However, that's not a fast failover, right? I'm sure there's a resolver timeout you can configure somewhere, which I've never really dug for. But when your primary is down, the first couple of queries that you try to make are going to be severely delayed. And then every so often after that, it's going to retry that primary and they'll also be delayed. So if you start seeing weird DNS like resolution slowness, check your primary. It could be down.
Right. And I think we've done better at setting the default timeout on those resolver requests to where
Mhm.
a few seconds. And in fact, we could try it right here.
But a few seconds on all of your database queries because your application is looking for the database by its DNS name would really add up quick. DNS is involved in so many things that it's when things don't work right, you really get out of sorts quickly, and sometimes it's not easy to track down.
Yeah. So it was, I think, about a second that it waited,
Okay.
moved on to the next one. But yes, on different versions of Linux or even different Linux distros, that can be different. So it might be several seconds, or it could be a little bit faster, like what we see here on RHEL 9.
Right.
All right, but I know this is a bogus name server, so I'm going to go ahead and remove it.
Good idea.
All right. So that's a little bit on the resolver configuration file, right? Who do you talk to? What additional options do you have? There was a options line, and honestly, I've never used it, so I just left that one alone because I had not used it before. The other thing that we're interested in, why I installed bindutils at the beginning of the critical path here, is there's a selection of query utilities. So the most simple one is host.
Hmm.
Right? So host is just a command line utility that like looks it up and provides a response. Another really old one that many people are familiar with is NSLOOKUP. And NSLOOKUP gives you a little bit more. Not only does it give you the answers, just like host did, right down there at the bottom, but it also gives you the server information up here, right? This is when we did this DNS query, this is who we asked, right? And that was based
Right.
off of conf. So you're given that additional information. The other thing that we're getting given out of here is this. So we had to go out and ask a name server, but it turns out that name server is not the one that directly holds the records for redhat.com. He had to ask another name server that does hold the records for redhat.com to answer the question for them. And so that's why this answer is a non-authoritative answer. We had to ask somebody else.
Right.
If your server is the one that holds the DNS records, and we'll actually do that after the critical path today, then this tag of non-authoritative answer will not be present. All right, the last one, which is actually the most name servery, is dig. All right.
Dig is good for looking up well, it's good for really digging in to a record.
So a couple things. One is you actually get a little bit of diagnostic of like what's happening during the query. If things are slow, you can actually see these things being staged. It actually restates the question, right? So what you asked for was a address lookup, right? That's what the A means for www.redhat.com. And the answer section is, I did that address lookup, and here's what I got back. And what we get back is that www.redhat.com is actually not a single server. It instead gave me a CNAME record, a canonical name record of this other machine. And then it goes into a little bit more detail. And eventually we get down to an IP address after we like pass through a bunch of CNAME records that eventually will resolve to an IP. And then the thing at the bottom, this is a little bit more detailed than what we got out of NSLOOKUP, right? It tells me the server that we asked the question to. It also tells me how long the thing took, as well as the amount of data that was provided when we asked the question of that server. So dig is the like most verbose of all of the tools by default. And host is the least verbose of all the tools by default. All right. So
I would argue that dig is also the most versatile.
it has a lot of like really cool things. We'll take a look at a
Yeah.
couple of things in the deeper dive.
Right.
All right. So stay with us after the transition. We're going to be talking about more about DNS. For example, did you know that Red Hat ships multiple packages that do DNS-y things? We're going to talk about it. And then we're actually going to set up a couple of different types of DNS servers. So stay with us. Don't forget to mash that like and subscribe. See you after the transition.
It's not DNS.
Sorry, Nate, I cut you off. It's not DNS.
Welcome back.
This is what happens. So, for those of you who don't know, producer Eric is no longer with us. He still lives. He just doesn't hang
But
out
he's
with
dead to us.
That's right. He found another great opportunity within Red Hat and decided to move teams. So yeah, you're stuck with me doing producering, and then we have things like I smash buttons before Nate's finished talking, and here we are.
Yeah. Well, that was also, I tried to throw that in there to be funny, and
It's your day job, Nate. All right. So here we are. Now is also the time where we can answer questions from our audience.
Yep.
If you're a preferred viewer, please feel free to leave comments. Nate and I do review and respond to them.
So Shantanu's curious if Red Hat uses bind for DNS or not, and I have no idea. I don't know what we use internally. But we probably did at some point. I don't know if we still do.
Oh, we definitely did at some point.
Yeah.
Because I happen to know the people that did it. But it's also fairly common once you get to be a certain size that you use other tools for doing DNS. In fact, many people use external tools for DNS
Yeah.
because there's things like, how do you survive a denial of service attack on your DNS?
Yeah.
Where if you only have a couple of servers, that's a concern. But if you're using a external service that has tens or hundreds of servers, that's less of a concern.
Yeah, most cloud providers nowadays, and a lot of other third parties that you can pay specifically to give you nice, robust DNS services. DNS hosting is, especially on your cloud provider, is either free or super cheap. It like super cheap. I used to do all my own DNS, and slowly but surely moved over to two different cloud providers that I'm using for DNS. They're both free. They both work really well. I don't have to worry about DNS infrastructure being up or down, and it just works. On the flip side of that, it means that slowly but surely, like personally, one of my first projects when I got into IT, when I was like learning IT and how all this stuff worked, was I registered a domain. I set up a name server. I figured out how registrars worked, and like that was a really cool project that really got you in, like into the weeds. That's not as much of a thing anymore, right? So kind of makes me sad. But on the other hand, DNS is so important, right? That it's like, I don't know. It's a double-edged sword. Hosting it yourself can be fun, can be rewarding, can be interesting, but if it's down, like it's a big headache.
Right. And I will say that I also used to run my own DNS on my home network, and I have slowly over the years now moved to a service that I pay for annually that does that. So I
Yeah.
maintain records there instead. Mostly because when DNS is down, like all kinds of bad things happen. Uh,
Yeah.
so oftentimes your DHCP lease is what gives you your DNS server settings. So like here we are in my home network and like all of my smart TV.
What just happened?
That's weird. All my smart TVs and laptops and everything else um, all get a DHCP release that had my local DNS server. So if the DNS server had a problem, like it powered off or what have you, um, then none of my home devices would work. And my spouse would be very disappointed in me and a little bit frustrated that all of my devices at home were not working. That
Why can't I watch TV anymore? Oh,
ex-
because DNS is down. What?
so we solved that by putting it outside and letting someone else take care of the resiliency and redundancy um, that that's needed for it. But Nate, you mentioned home labbing is a great reason to do your own DNS.
It really is, and there's a couple ways to get that done. We're going to talk about Unbound today, which is a caching, primarily meant to be a caching DNS server that you can run, and it's included with RHEL. I guess we didn't talk about the other options. Are we going to talk about that later, Scott? Because
Well,
there were,
also, we're also going to cover Bind today, which is the like
yeah.
additional service for doing DNS on RHEL and Linux just generally. It looks like we're having restream problems today.
Ah, there we go. Restream is really trying to mess up our day. I think Eric is secretly hiding in the background, messing with our buttons. Anyway, you were saying about
Yeah. So Bind we will cover today as well, and then there's a third program that Red Hat ships called dnsmasq,
right.
and dnsmasq came in the distribution when we started doing virtualization. And so it was included in that virtualization stack, and it provides not only DNS services but also DHCP services and Pixie services.
Yeah.
And it's meant to like run on your hypervisor and provide those services to virtual machines that are booting on the hypervisor. So when you do like dynamic DNS, it can take registrations and create DNS records locally in the hypervisor for those machines running on the hypervisor. That one we're not going to cover today because it is pretty tightly coupled with virtualization, at least for Red Hat. So we're going to focus on Unbound and Bind.
Cool. All right, so I do have a demo quick on how to set up a quick caching only name server with Unbound. So we can pop that up on the screen. Now I've got basically a plain old rel box here. There we go. There we go. I've got a plain old rel 9 box here, and I have not even installed the package yet, so figured we'll do that live as well. And it's really simple. It's just DNF install unbound. And this will go out. It'll get the packages for the unbound server. I forgot the -y. I'm wasting so much time here. Okay, so there it is installed. Of course, it's a service, but we're not going to enable it just yet because we have a bunch of configuration to do in order to get this running. Out of the box, it really won't do much, right? If I started up the service, it might accept local queries, but that's about it. And what I wanted to demonstrate was, say you wanted a local caching name server on your home network or maybe within your enterprise network. There's a lot of reasons why you might want a caching name server for things like improved query responses and whatnot for, I don't know, like that database example I was using earlier. If you have a DNS server that's local to your network, then the latency to reach it is a lot shorter. Plus, you can set up things like Unbound to let you do stuff like DNS rewrites. So if you had like local addresses that are just local, that kind of stuff. So let's look at the config file. Good old unbound.conf here. There's a line down here that tells it what port it needs, or not what port, but what interface it should listen on. And there's a couple that are commented out here, as you might expect from other services you've seen installed on RHEL. There's like some examples that are already in here. Normally, I would not say listen on any interface, but in this case, I'm going to because this is just an example. There's other examples here for things like I'd like to listen specifically on this IP address, this IPv6 address, things like that. So you might want to check those out if you want to be a little more tightly configured. All right, the next thing is there's a configuration option that tells it to automatically choose the interface that it should be listening on. And by default, it's set to no. You see down here, it says interface automatic no. That's because it even says right here in the configuration that is because of a policy of not listening open on interfaces within Fedora, which of course came into RHEL. So we're going to comment that one out. And like you just saw me do, I uncommented this automatic or interface automatic. Yes, right. This will tell it, yep, go ahead, listen, pick an interface and open it up. Again, this is this sort of thing where you're going to want to look a little more into that if you're doing this in a production use case. You can change what port it listens on, but I don't know why you would do that because DNS is meant to listen on 53, and if you move it elsewhere,
I would not do that.
Things are going to get confused. There's really no reason to move that. But if you needed to, there it is. All right. Let me look at my notes here. There were some other things. Oh, the cache timeouts. Let me switch. All right. So this is way down at line 203 of the configuration if you're following along at home. You see there's cache TTLs here. There's a minimum TTL and a maximum TTL. Now, the minimum TTL will tell it basically the minimum of how long it'll hold on to a cached entry, and it's currently set to 0. I want to increase this to something higher because what it'll do is whenever it asks an authoritative or external name server for an address, it'll save that locally for a certain amount of time. Now, you could set this really long if you want to. But the downside would be if the authoritative answer changes, your caching name server won't go recheck for it until it meets this number, right? So if you set it to like a month and you get a DNS query today, 30 days might go by before you ever find out that DNS address has changed, right? And you probably don't want to do that. So something like a day, half a day, a couple hours, probably safe, right? So I had jotted down, and this is in seconds, right? So I'm going to set it to half a day, which is 43,200. And the max TTL, this basically says, do not hold on to a cached entry longer than this, right? So if it meets the minimum, it may go and get a new version of the record. If it meets the maximum, it will definitely go get a new version of the record. So that's what these two settings are for. All right, and then the other thing we have to do, because I want this to listen on the network, not just locally, we have to. There's an access control list that's in here as part of the configuration, and that's on line number 294. Okay, so you see here there's these access control statements, and there's a short description at the top there about what these mean. And I'm not going to go too deep into this, except that you need to add one that says access control colon, and then I'm going to make it listen. I'm going to say, go ahead and listen for anything that's on the network that I'm on, which I'm going to go really broad on this, is 10.0.0.0/8. And that allows the entire 10 dot anything, class A, if you want to call it that, address range, right? And I'm using that because these particular lab systems I know operate within that high level of a range. Sometimes the subnet, like the second, third, and fourth octets, will be very different, but I want to cover all of them. So that's why I did it that broad. You obviously would want to set this up to whatever's local to your network, right? So if this is your home network, you'd set it to like 10.1.2.0/24. Might be, something reasonable for your home network. 192.168.10.0/24. Just examples. Okay, and then that should change. That should configure unbound so that it'll now listen. So if I do a systemctl enable. Oh, actually, there's actually a nice thing called unbound. What was it? Unbound dash. No, dang it. Unbound checkconf. If you run that, it'll check for syntax errors within the configuration that you just made. And because I made all those changes, it's a good thing to just kind of test quick. So now if we do systemctl enable now unbound, it's going to enable the service and start it up for us. And now if I did like an SS and look for open ports, you should see port 53 is open now. And it's being served by unbound. So there we go. Now our DNS server is up and running. So now what we should be able to do, remember those tools we talked about earlier? If I do a dig at 127.0.0.1, actually, will that work? My access control list might stop this. Let's find out. Nope, it got the answer because it's on localhost. And I think there's a default that says, yes, we will listen on localhost. So there we go. We have our response for redhat.com from dig. Like I said, one of the tools we did earlier. And I've also, like I said, I configured it to listen more broadly than just localhost. So I do have this second host over here. If I do the same command, oh wait, I need to get the IP first. I broke instruct, Scott.
Click the wrong button.
Hold on. All right. Here we go. We've got the IP address that we want. We're going to go over here and do dig again. The problem is it doesn't highlight. It doesn't put it in the terminal when I switch tabs. That's what happened. Dig at, and then we're going to put in that IP address, and then we're going to go. Now remember, right? This is not unbound on this machine anymore. I've gone to a second host. It should reach out across the network and ask my other host, "Hey, what's redhat.com?" And there you go. It got the answer, right? So this means that it is actually working on, the network instead of just my local machine. And like I said, the reason I think this is cool for home lab stuff is you can set up local overrides so that www.home.lab goes to your development web server, right? And then that doesn't mean you have to set up this big DNS infrastructure to make that work. It just queries this name server. It gives you the address and you're good to go.
Yeah, and so primarily Unbound is used as a caching name server, which means it relies on the name servers out there in the world for the answers that you're asking it, like www.redhat.com. But it also remembers that answer. So the next time you query redhat.com, it goes to localhost and doesn't have to traverse the DNS infrastructure of the internet again.
Right.
It can lead to faster resolutions for things that it's got in its cache. And over time, that cache will build up and you'll have more and more records in it so that you're not traversing the internet for every DNS query that you're using or your ISP's DNS for every query that you're doing, in addition to being
Right.
able to hand select the overrides that you want to reside on your network.
Right. So, a really good use case for that is, you've got some high performance application that needs to look up DNS records quickly. You could put a unbound server on the same network as that machine, or heck, you could put it on that machine, right? Then it's literally a local resolver. That'll be as fast as you can get. And then once it has those records cached, until that TTL is reached, it'll just query its local cache instead of reaching out to the internet to get that every time. Now,
The-
your DNS resolver stack will also cache, right? So there's a couple layers of cache there, but just keep that in mind.
And for those uninitiated, the TTL is the time to live of the record in cache.
Yes.
And we can actually see that in the dig output, right? If you look at the answer section, the www.redhat.com line, 43,132 seconds, that's how long that record should persist in the cache of your caching DNS server.
Yep.
So after that
Yep.
time has elapsed, the next time you do a DNS query, it'll actually traverse the internet again to make sure it has the right information.
Now this is actually kind of fun. Remember when I set up Unbound, I set the minimum TTL that I want Unbound to cache it. Do you remember what I set that number to? Or were you busy chatting?
I
I
was
don't
not.
have it over here anymore. I set that number to 43,200. So this is actually telling me what Unbound said, how long it'll hold on to this record, right? If I were to do the same query again, it should be down by however many seconds have passed since the last time I ran it. There you go, 42,950. So, just validating that what I said in Unbound is in fact true. But
Well,
yeah, basically whatever DNS server it got it from is where that's going to come from.
yeah, and as a DNS server administrator, I can tell you that it's kind of obnoxious that you'll have things like this. Nate's now running this caching only name server that's cached this record.
Yeah,
Well, at Red Hat, if I make a change to what that DNS record is, Nate won't see it for another 42,950 seconds. He'll still be using the old record.
right.
And so when you often, if you put in a request to change a DNS record, or you're using one of those services that we were talking about earlier, and you put your change in, there's often a message that's like, oh, it may be up to a week for this to take effect, or something
Right.
like that.
This is
And
why.
right, because all these other DNS servers out in the world have cached the old record that you just updated, and you're going to
Yeah.
have to wait for their caches to expire for them to get the new record that you just updated. And there are a
Now
couple to try and address that, but
the authoritative name server has its own time to live as well, which I believe will override these, but I'd have to try that out and make sure. I think it will. I don't know about in the case of a specific caching name server where I have defined the minimum how long it keeps the record. But I know that if you're not overriding it on your local name server, then if the authoritative name server says these records only live an hour, then once an hour passes, things are supposed to go and refresh that.
right. But the flip side is if you set it to an hour, now every hour you have
Yes.
ungodly amounts of machines calling in to get DNS.
Yes.
And so it's often the case to reduce the load on your DNS infrastructure that you actually set that time to live higher. But then when you start to make changes, you have to wait for those changes to propagate.
Yeah.
Again,
When I was
had 3 servers, you had to care about that because you didn't want to kill your 3 servers with
right,
load. But as you move into like the cloud and other places, it's less of a concern. You could set those time to live smaller.
because it's not your infrastructure you're worried about. It's somebody else's server. Yeah. When I was doing this manually, I mean, it was really common to see those set for a day, right? Which is where that 24 hours, it could take up to 24 hours for these things to propagate, became like commonplace. So
Yeah, and when I would do it for a large telecommunications company, um, we would do DNS updates like every few days,
mhm.
um, and we knew it was scheduled, so we knew that that time was coming up. And what we'd do is we'd go in and change the time to live to be something small for the zones that we were updating, so that we'd have a couple of days of all those servers calling in and getting the time to live lowered, so that when we made the change, it was more immediate. And then we'd go in and up the time to live once the change was made, so that the next time they called in, they'd get that um, longer soak time on them.
Yeah, and that's also tricky because if the TTL was long and then you made the change, but before you made the change before the TTL expired, then things that had cached it still had the old TTL. DNS can get really complicated.
Well, and so what we do is we had our default time to live was 1 day. So we'd go in a couple days in advance and
Yeah,
look like 60 minutes. So every
right,
hour we're calling in for 1 day. And then
right.
we'd process the change, and then we'd have to wait for an hour or two. And then we'd go in and update the time to live to be longer. And they would all pick it up within an hour or two. And now we're back to that 1 day time to live. And so it was very purposeful that, like, okay, we know we're going to make this change. We're going to make this change on Wednesday. So on Monday, we're going to adjust the time to live records on all these zones that we know we're going to change on Wednesday. And then we make the change on Wednesday. And then after we make the change on Wednesday, we set it the time to live back, and it went back to kind of normal operations. Woof. Well, we've talked a lot about DNS servers, but we haven't actually talked about the big DNS server that comes with RHEL, which is bind. So why don't we go ahead and jump into that? So I'm just going to install bind, which, remember, is the Berkeley Internet Name Daemon. And bind is one of the weird services in Linux where oftentimes it's packaged with the word bind, but that's not the service it provides. Instead,
Yeah,
yeah, the service is called named, right? Because it's the
right.
name daemon. So while we install the bind RPMs or the bind packages, the actual daemon that we're controlling with systemd is called named. All right, so there's a configuration file for it, etcnamed.conf. And I'm going to make a couple of changes for the purpose of this demonstration. So just like we saw with Nate's unbound demonstration, there's a listen directive that tells it what to listen on. And so I'm going to say to listen on any interface connected to this machine. The default is configured to only listen on localhost for local resolver capability. You could also have a list of IP addresses or interfaces that you want it to listen on. Any just says scan and listen to them all. All right, like Nate was saying about unbound, by default we listen on port 53. You could change that. You probably don't want to, because all of our default tooling will use port 53, and things like uh, web browsers by default use port 53. So if you change the port, all of a sudden, like, a lot of weird things start happening with your
Yeah,
DNS.
and if this was an authoritative name server, I don't even know how other name servers would find you if you had a separate port listed. Like, I don't think that registrars even let you specify a port. It just you
Right.
listen on 53, dummy.
That's yes. So you can change it. Don't.
Yeah,
Um,
don't change it.
uh, the directory setting there. So this is where all of my zone records are going to be stored. So domains are also known as zones. And so I'm going to have a zone called example.com that we're going to work with. And when I put all the DNS records for example.com together, I'm going to put them in a file in var named. That's the default location. Um, Allow query. So who can ask this DNS server questions? So by default, only local host. So I'm going to go ahead and change that one too to be any. Whoops. There we go. In reality, I might only want certain interfaces to be able to receive queries,
Right.
just scan and attach them all. All right. So down here are some other things, like should I allow for a DNS sec? And the default is yes. But we're not going to cover how to configure DNSSEC or do anything with certificates or anything like that today, because that's a whole nother beast. And then a couple other things like what's the PID file where we track the running name daemon? How do I do logging? And then down at the bottom, there's a couple of default settings like what is the name server I should query if I don't know the answer, right?
Yeah.
So that file namedca is just a list of name servers. So that if your name server is asked a question and it doesn't hold the records for, it'll bounce out to one of those on that list to try and retrieve the answer for you. Not a-
It's been a while since I've done bind. Is that referring to the root servers?
It is referring to the
Good.
root servers.
Okay.
All right. So to get us started, I'm going to add a new zone of authority into this named.conf. I said that we were going to handle a zone called example.com. Here we go. So I'm responsible for the zone example column. It's an internet zone. Type. You can use master, but that's an outdated term. I prefer primary. You can have more than one name server, but you probably don't want multiples of them to be primaries because then if you needed to make changes to records, you'd have to go to them all. So in a
Yeah.
multi-DNS server setup, you have primary and several secondaries. And the secondaries will periodically pull copies of the zone records from the primary, but will equally serve them to clients. All right, and then that file there, so that's the file that I'm going to create out in the var named directory that's going to hold all of my records. All right. So that will get me started. Whoops. All right, then I'm going to go out here to the var named directory and I'm going to create my initial set of records for this zone. So in my configuration file, I said look for a file called example.com.zone. And then there is the records I'm going to put into it. All right. So I generated this last night so that I could test and everything would be cool. But let's go through and talk about what all this stuff is. So in this file, a semicolon is a comment. So you'll see like at the top level, there's a semicolon and some words. That's a comment. You could see down in the start of authority record over here, right?
Right.
Semicolon and then some stuff. Well, everything after the semicolon is a comment. So you can put comments on the lines of data as well. You can mix data and comments together on the same line using the semicolon. All right. So back to the top. We have a comment, time to live. So if I don't tell each individual record a time to live, this is the one they should get. So when we were talking earlier about how long records persist in caches and other stuff, this is how long in seconds it's going to be, and it's 1 day. So we'll keep them there for 1 day. There's a variable called origin that you can use. So later on in my file, I could refer to $origin, and it really means example.com. But you'll notice that there are no references to that later on. So I set that variable, but then I never used it. All right, then we get something weird. This hunk right here. This is traditionally what starts your zone records, and it's called a start of authority record. The @ sign is the origin, but basically resolved to the origin. So I could also put in the word example.com dot instead of @ but @ is a shorthand for the same thing. It's an internet record. It is a start of authority record type. And then we get the 2 DNS servers that are responsible for serving the records from this zone. And then there's an open parenthesis and a bunch of stuff and a close parenthesis. That bunch of stuff is for how other name servers should treat this data. So there's a serial number, and that's used to track the updates for this record or this set of records. It's primarily used for the primary to communicate with secondary name servers that the primary's records have changed, which means the secondaries have to update their records too. It is just a number, and a bigger number means there's been a change. Traditionally, what we use is an ISO formatted date and a 2-digit revision number, right? So
Yeah.
the last time this records were changed was 2024-10-04, which is the date of today's episode. And this is the first change. So 01 is the change number I put in there.
I've seen some DNS zones that start at like 1 and they just increment the serial as things increase. But if you're doing this in an automated fashion, that might be fine because there aren't people that have to parse this. But if people look at that serial, then they don't know things like, when was this changed last? This is a good way to say this was last changed on October 4th, right? So
Right. And
handy if you have people in your DNS zones, not just computers.
so every 1 day, secondary servers should try to refresh their zone. So they'll call in every day, they'll check their serial number against the serial number the primary has, and if there's no change, we're good. If there is a change, then it'll pull down a new copy of the records and recache them. Update retry. So let's say it's been a day and the secondary calls into the primary and it doesn't get a response. So it's going to wait 900 seconds and then check again to see if it can get a response. And if it still doesn't get a response, it'll wait 900 seconds and keep trying. The expiry is after I've been calling into the primary name server every 900 seconds and I still haven't gotten a response. At some point, I'm going to assume that the records I have on my secondary server are out of date and should no longer be used. So if we've been trying every 900 seconds and it's been 604,800 seconds, which I think is it's like 5 days. After 5 days of not being able to get a response from the primary name server, the secondary name server is just going to give up and not service these records anymore.
That might be 7 days.
It might be.
Might be 5.
Maths,
Somebody calculate it. Put it in the chat. JScar, where you at? I see you in the chat. Come on, give us.
So that's the start of the authority record. Every DNS zone will start with one of those. And it's mostly around like tracking updates and then also how should secondary servers treat the records in this file. All right, then we get a couple of other types of records. So the first one is an internet name server record. So
there it went again. I'm telling you, Eric is in the background.
So the name server record, this is the machine that's responsible for serving as the name server for this this zone. The other that we see here is an MX record. When we send mail to machines in this we send mail to machines in this domain, who should that mail go to? So it should go to a server named mail.example.com. You can have multiple mail servers, and that number that's there is the priority. So if we're not able to contact a mail server, maybe we should try another one on the list. And if we're going to have multiples, should we have one that's preferred? And so that number sets the priority. All right. And then the last record I've highlighted is an address record. This is a traditional, like normal record to see in your DNS server. So we have a machine named rel.example.com. And if somebody looks up rel.example.com, we should tell them the IP address for that host is 10.5.0.111. And we can see the next one down. There's client.example.com. And when somebody does a DNS lookup against client.example.com, we should give them back the IP address 10.5.0.49. All right. And then at the very bottom, we see one last type of record, right here, it is a CNAME record. So if somebody asks me for rel client.example.com, I'm going to tell them that that's client1.example.com, which is then going to ask me who is client1.example.com, and I'll give them back the IP address 10.5.0.49. So a CNAME record is an alias record, right? It's a way to have another host name that points to the same system. We could also do an A record. I don't like doing A records because if I have multiple A records for the same host, then if something changes, like it's an IP address, I have to find and replace all the places where I use that IP address. Whereas with CNAME records, if I change the IP address associated with client one, then any CNAME record will automatically pick up that IP address record change. Because
The only caveat, I guess, would be that turns into 2 DNS queries where maybe one might have done, right? So if you're in a situation where that matters, just keep that in mind. If I looked up rel client, then my resolver is going to be told, okay, now go look up client one, right? So turns into 2 requests. And if that's also a CNAME for something else, I don't know. I think DNS eventually has like a limit to how many times it'll follow them. But
it used to. I don't know that it does anymore. But
yeah,
honestly, if you're like hitting that limit, you're doing it wrong.
exactly. But if you have like a CNAME of a CNAME of a CNAME of a CNAME, then it gets to be really inefficient.
Right.
So, and some other cool stuff you can do with these records is if you had like 2 or 3 records of the same name, it'll do round robin returns for those. It'll give you the first host, then the second host, then the third host. So it's like a cheap way to do not quite load balancing, but if you have several hosts that respond to the same thing, you could have it done that way. Same deal with MX records. I forget if I didn't hear if you had gone into detail on that. If you have more than one mail exchanger for a domain, you can have several of them, and then you assign a priority to each. That's what that 10 was. You could do a 20 and a 30 and a 40, right? So interesting stuff that you can do with DNS records that are a little bit, I'm not going to call them advanced, but they're outside of the normal like use cases.
Yeah, the DNS round robining, which is assigning multiple host names with different IP addresses to try and get that that load balancing, is fairly common.
Yeah.
But the other things are less so. All right. So I started up my named daemon. No errors. That's good.
Yay.
Yeah. And if we do a systemctl status, right, we actually down here at the bottom are told like, hey, we're serving the localhost zone or the reverse lookup localhost zone and the localhost zone and example.com zone. Yay, that's what I wanted. Right? That's the one I just put in. And we can do things like dig at localhost, right?
Yay.
Get queries back from our name server. And I have this other client over here, and I already took care of adding my new name server to its resolve.conf. Just make sure here. Oh, helps you put in the right IP address.
Is there too many ones or something? Oh, okay. Oh, a little bit of transposition there. There you go.
So this other client is now querying my local name server to get these records, right? And then we can, with dig, do things like, hey, give me the MX type record from this host.
Yep.
So you can actually specify what kind of record you want if it's not just an A record. All right.
There's a bunch of other record types that we probably didn't touch on. A quick list would be things like CNAME, SOA, and MX we already touched on. TXT is a text record, which is literally I ask DNS what is the text record for a certain host, and it'll respond with text instead of a number, right? So this will be used for things like Some of the more advanced things are like, what's the Kerberos realm for this domain? Could be in a text record. But easier things are like, what's the SPF, which is an email routing, security feature. Um,
And I actually have one of those, Nate.
oh, you do? You do have a text record? Or you have an
There you go.
example of a text record? There you go. There's a DKIM record.
Yeah, so DKIM is a way that mail servers can identify their authenticity. It's a way that we help fight spam as
Yeah,
well as people masquerading as someone else by kind of uh, sending mail with their identity, even though they're not the authoritative mail person. So let me. That's about as good as we can do. But so for my mail server, right, which higher up, we said the mail exchanger was this machine called mail.example.com. For my mail server, there's a text record, and here's the stuff in the text record. So like mail infrastructure actually will do this DNS query
yep,
to check DKIM record and the key that validates the identity of the server.
right.
So from a client side, let me right quit. Oh, and it's always good policy to go ahead and update my serial number, right? Because I just made a change.
Yep. Yeah, if you don't update the serial, that can also get you into a weird state where if someone queries the authoritative server directly, they'll probably get the right answer, but anybody else will still have the old records.
Right. All right. So over here, I can do a dig mail.example.com text records.
Yep,
And there in the answer, right
there's the
there's
text
the
record.
.com text record I put in.
Now, if you've ever had to like validate your domain name with a third party service where you're like, "Yep, I totally own that," sometimes they'll ask you to put in a text record. If you use Let's Encrypt can use text records to validate that you own a host name before it generates you an automated TLS certificate. So there's lots of uses for TXT records. This is just one of them.
All right. So there is another pretty important type of record that we've not covered yet, and that's PTR records.
Yeah.
All right. So things are about to get wild. So we've spent all this time focusing on going from host names to IP addresses so we could then send that IP address network traffic. And that's where most people's understanding of DNS is based. But DNS is also responsible for the opposite.
Yeah.
Somebody gives you an IP address and you have to figure out the host name that goes with it.
Yeah, so the first type that you just referred to is usually referred to as a forward lookup, although no one uses that word unless you're really like talking about the specifics of DNS. A forward lookup is when you're saying, "Here's the name, I need to know the IP address." What Scott's going to touch on now is what's called a reverse lookup, which, as you might guess, is the opposite of a forward lookup. I have an IP address, I need to know what DNS name associates with it.
Yeah. So I already did the creation of this and tested it out. So I'm just going to copy and paste my zone file in. And it looks very similar to the zone file that we just saw for example.com. All right. So let me just make it a little bit easier to read.
Now, generally, you only have to care about these if you own a block of IP addresses, right? Like if you're using someone else's address space, like you're on a cloud provider, your ISP gave you some IP, something like that, they're handling reverse for those zones. You don't have to worry about this. However, if you own IP space, which not a lot of people do anymore, but large corporations do, then you are responsible to publish reverse entries for the IPs.
Well, this is also a place where running your own DNS infrastructure is useful
Right.
because things like there's a lot of stuff that will end up doing reverse lookups. And if it's internal to your network, your DNS server can service those reverse lookups, right? Like I don't own this 10.5.0 address space, but because all of my machines use my mail or my DNS server, I can provide the records for this reverse lookup zone for them. All right. So what's special about it is the zone name. So with forward lookups, we're talking about example.com or redhat.com or floof.net or whatever it is, right? The word-based DNS name extension, the zone that we're responsible for. But for reverse lookups, we're interested in in-adder ARPA zones, right? Internet address ARPA tables. And then in addition to telling it that it's an internet address ARPA table, you also have to say, what is the network that these records correspond to? And notice it's written backwards. And there's a lot of trivia of like why that is. It's dumb, but we write it backwards.
It is funny that it's backwards, but it's a reverse zone, so it makes sense, right? That's how I always remembered it.
So for the 10.5.0 network, I'm going to serve all the records for those. So I have two actual PTR pointer records in here. So 10.5.0.49 and 10.5.0.111. So if you do a reverse lookup on either of those two, I will give you the associated host name that goes with them. All right. The real reason it's written reverse is because DNS forward lookups go from most specific to least specific, right? They go from my host name on a domain on a super domain, right? rel.example.com. Host name, domain, super domain. But IP addresses are organized the exact opposite way, right? They go from like Giganto network 10 to subnetwork 5 to another subnetwork 0 to the actual host's information, which is that last octet. And so to not have to rewrite the parsing for how we do DNS lookups, we just said, we'll make all the administrators write it reversed. Done. So that's why that is. All right, so here's my records. Let me save and quit. And then I'm also going to go into Etsy named.conf. And we're going to add in another zone of authority that my DNS server is responsible for serving. And it looks like this. So for the 0.5.10 in-adder ARPA domain, I'm the primary. Here's the file where you can find the records down in the var named directory, which I just showed you. And we're going to do a systemctl restart named. And over here on the client, dig-x will do a reverse lookup. And there's the record. But if I look up something that doesn't exist, like 3.
Right.
There's no matching record in the zone file, right? Because I only put 2 machines' IP addresses in there.
Now, this is something that maybe, a lot of people are never going to bother to look this up. There's certain troubleshooting reasons you may want to do a reverse lookup on an IP address, but in a lot of cases, and I'm thinking like there's a lot of email use cases. If you don't have reverse set up for an IP address of a mail server, for example, the recipient will treat that poorly, right? They'll say, wow, there's no reverse for this, so that's going to count against you in whatever heuristics it's using to judge whether you're a spammer or not. So important stuff if you're doing other infrastructure-y things like running mail servers. And there's probably other things that treat it in similar ways, just like IP reputation type stuff.
And the reality is for every forward lookup, you should have a reverse lookup to go along with it.
You should. You should.
They're all focused on getting, I put in this host name, here's the IP address I get back, but they don't pay attention to plumbing it the other way. So if you put in the IP address, you get the right host name back.
Right.
And sometimes you can't. Like your internet service provider at home gives you an IP address, and they have in some table somewhere your reverse lookup zone, and they have a host name assigned to that machine. You won't be able to change that because you're not the authoritative person on the internet for
And
that IP address.
that's exactly why spam reputation services will treat reverse so harshly. Because if you're just like a client who stood up an open relay on some guy's Windows machine and you're using it to forward spam through, then the reverse isn't going to match the forward. And they treat it like, well, that's an indicator that it could be something nasty going on. So
Yeah. There's all kinds of like DNS stuff that goes along with mail reputation specifically. So
yes.
VF records, DKIM records, reverse lookup records, DNS blacklisting, which is like they put in records in service that other mail servers connect to that says like these are the host names you should do away with. Yeah.
If you want to talk about hacky ways to use DNS, a blacklist hosted in DNS, all text records. Yay!
All right.
How else do you make a published, blacklist like that that's easy for everyone to just query quickly? Yeah.
I mean, when you're a hammer, all the world is a nail, Nate.
Yeah, exactly.
I think DNS.
All right. Well, so we went super long. I hope there's no more demos.
No, that was it. But like, can I, in good faith, cover the forward without covering the reverse? I don't know.
No, you can't. Reverse is important, but only to the people who have to care about reverse.
Right. Most people are most concerned with forward and forget. But
yep.
All right. So, man, you've made it this far. Hit that like and subscribe. Secondly, next week, Nate, you're going to be off doing something fun.
Yeah, it's 21 years, Scott. 21 years of marriage. So I'm out next week celebrating with my wife. So you guys can all have fun with Scott next Friday.
Yeah, so I'm going to go it alone. And this morning, Nate and I were like, what am I going to be doing? I have some ideas, but I'll make sure to publish it into our channel earlier than I did this week. So think about between Monday and Wednesday. I'll have it there.
I'm sure there's going to be a whiteboard, though.
We'll see.
Scott loves his whiteboards.
I do. I'm thinking something like memory management-y, maybe a little bit more esoteric next week.
Cool. You've always wanted to delve into those crazy deep ones, so maybe you guys will be in for a treat next week.
And then with Eric's departure, RHEL Presents is going to be put on hold. The good news is we are expecting a new member of our team at some point. But until we get that person, we're going to put RHEL Presents on hold since Eric isn't here to host and manage it. And once we have another person on the team, we will figure out how to get that thing restarted. So no RHEL Presents for a while, but we'll continue to do weekly episodes-ish of Into the Terminal. And I think that is it. So until next time, until next week.
It was DNS.
It's DNS.
Have a great one, folks.